Hello students, I am Professor Prakash Naik, HOD of BCE Department, Anjuman Institute of Management and Computer Application Badgar. In our previous video, we learnt about files data structures. In today's session, we shall learn about linked list. So, let us start the session. So, this is a snapshot of memory. Memory is a long strip of bytes, and each byte is having its own address, extended both on the left side as well as on the right side. I am taking this address starting from the address 100. The next byte will be 101, then 102, then 103, 104, 105, 106, so on. Memory is a crucial resource in the system. We don't have unlimited memory in the computer system. It is the responsibility of the memory manager to manage the resources to which the process is to be allocated, which memory is free, and how memory is to be allocated. Like this. Memory manager takes care of all these resources. Now, a programmer wants to store a value 5 to a variable x of the data type integer. For example, now on the computer screen you can see int x equal to 5. This means a variable x is declared. Now the memory manager will allocate how many bytes? The memory manager will allocate 4 bytes. Now assume that the memory manager has allocated 4 bytes to the variable x. Starting from which location? You can see here, let us assume here it has started from the location 113. From 113, it consumes how many bytes? 4 bytes. 13, 14, 15, 16 here. So 13 to 16. 13, 14, 15, 16. 4 bytes is allocated. And in this location, what is stored? The data 5 is stored. Now, again, the programmer wants to store 3 more values. The programmer wants to store 3 more values. We had learned the concept of arrays in our previous semester. So how will it declare it? It will be declared in this manner. You can see here data type int ARR array name in the square bracket 3. This indicates that 3 locations are to be allocated. The memory will allocate how many bytes? There are 3 locations. Each location will consume 4 bytes. So 3 into 4, how much? 12 bytes will be occupied. And these bytes will be in a consecutive locations like this. You can see here. So 4 bytes here, 4 bytes here, 4 bytes here. 4, 4, 8, 8, 4, 12. So let us assume that the first value is 4, the second value is 7, the third value is 9. Now assume that the programmer wants to store another value, the 4th value. Now the programmer will make a request to memory manager to extend the size of an array without declaring another variable. He says, I don't want to declare one more variable. In the same variable, I want to increase the size. And the previous data should not be harmed. So now the programmer says, I cannot extend the array. Why? Because after the 3rd location, in the 4th location, there is already a variable called as x. So it cannot be extended. What I can do is, I can give you a fresh location And in that fresh location, these values can be transferred to the new location. Can be transferred to the new location. So now the programmer thinks, in future, I may be entering 10 values or I may be entering 20 values. If I am entering 10 values, how many bytes is required? 40 bytes is required. If I am entering 15 values, how many bytes I require? I require 15 into 4, 60 values, 60 bytes. Now for a safer side, I'll declare the highest bytes. So I'll say int ARR of 50. If I say int ARR of 50, how many bytes? 200 bytes will be occupied. How much? 200 bytes will be occupied in this manner. So now, while entering the value, a person may not enter all the 50 locations. He will enter only the first 10. If he enters the first 10, it will occupy how many bytes? 40 bytes out of 200. That means the remaining 160 bytes is unused. And it cannot be allocated to any other variable since it is already allocated to an array ARR. So this becomes a wastage of memory. This becomes a wastage of memory. So what is the solution for this? The solution for this is linked list. Solution for this is a linked list. What is a linked list? Here it is. Linked list is a commonly used linear data structure which consists of group of nodes in a sequence. This linked list contains a series of values. It contains a series of values which are linked together. It is a collection of data elements which are not stored in a consecutive locations. In case of an array, the data are stored to a consecutive location, that is one after another. But in linked list, the data is not stored in one after another. One may be stored to one location, one more data will be stored to some other location. So they are not in a consecutive locations. And every location in a linked list is called a node. Now this node contains two parts. One is a data and one is a pointer, that is address of the next node. As you can see on the screen, a picture of a node, right? So here A is the data and this is the pointer, that is address of the next location. What are the components of linked list? The components of linked list is one is a node, one is the data or the information, one is next address, header node and tail. Now you can see a small snapshot of a linked list. The first node, you can see the value is 12. Right? This is linked to one more node. You can see the value is 4. This is linked to one more node. You can see the value is 6. You can see one more node. The value is 8. Right? And since this is the last node, this is called the tail. And the tail will not have any address of the next node. Whereas all the previous nodes have addresses. You can just look on the first node, which is called the head node. Head node does not contain any data, but it contains the address of the first node. So these are the components of a linked list. Now, let us see how the data is stored in the linked list. Now this is a memory picture. You can see here a number 2 is being stored to one location. Assume that it is stored to location 120. Right? In another place, in another location, number 5 is being stored. In one more location, the number 7 is being stored. In one more location, the number 9 is being stored. They are not consecutive. They are not one after another. They are stored in different locations. Now, in an array, there is a base address. There is an index. So, if we know the index of one value, we can predict the value of the next index. But here, in linked list, you don't have index. But instead, what we have is, we have addresses. You can see here, the first node 2, right? What is this location? This location is 120. This location is there in the header. Is there in the header. Whereas what is 200? This 200 is an address of the next node. That is, the value 5 is being stored to address 200. So this 200 is the address of this particular node where the 5 has been located. Then the number 7 is address what? Address is 340. You can see here, this is the address of the node where the value 7 is been stored. Similarly, the value 9 is been stored to an address 400. The 400 can be seen in this node. Whereas the last node does not have any address, it has null. So this is the tail, this is the header. So in this way, the values are stored. Now, how to declare a node? See, now if I want to declare a variable of type integer, what I'll do? I will take a primitive data type int and I'll give a variable name, for example x, or for example a, so that a will be holding integer type value. Right? Suppose if I want to store a floating point value, I'll take float. I will take float. Then, now here, what I need is, I need to store two types of values. One is of type integer and one is of type pointer. So for this, I need to declare a user-defined data type. To define a user-defined data type, what I use is, I use structure. And in short, the structure is written as struct. Struct is followed by a tag name. So the tag name given here is node. Within the block of the structure, so we have two declarations. So one is given as int x. So here in x the data is stored. 5, 7, 9, 10, 11, so on. All these values are stored to x. But here in the second line, what I have is, I want to declare a pointer which stores the address of the successive nodes. So here again, what I say? I say struct node and star and the address, the pointer name is next. The pointer name is next. In this way, what I do is I declare a node, and every time only one node has been declared. Every time, each time a single node is declared. So now, how much nodes are required? Only that much nodes can be created. We are not declaring this particular node is not declared at compile time, but it is declared at runtime. So when you run the program, at that time, what happens is these nodes will be created. Now, what are the applications of linked list in real world? One is image viewer. Now in Windows, there are a lot of images. There is a thumbnail of images. And I want to go through the previous image. I want to go to the next image, so on. So here I want to access the previous one as well as the next one. So image viewer can be one application of a linked list. Now in a website, web browser, we will be using a lot of web pages. Now I need to navigate from one web page to another web page. The previous page, the next page in web browser can be accessed in the URL by pressing the next button and the back button. Sorry, the previous button and the next button. Okay. Similarly, in a music player, there are long list of musical tracks, songs, and I want to go to the previous song, I want to go to the next song, so on. So this is also one of the application of a linked list. A video player can also be one of the applications of a linked list.